Alright students, so I'm on page 104 of the notes, and this is testing the difference of means when sigma 1 and sigma 2 are unknown. So we have two independent random samples from populations 1 and 2. We've got a sample mean, and we've got a sample standard deviations. We also have sample sizes for both. Our hypothesis in this situation, the most common for the null hypothesis, is mu1 minus mu2 equals 0, but you can write it as mu1 equals mu2, meaning there is no difference between the two population means, or in other words, the population means are the same. The alternative hypothesis in this situation could either be a not equal to statement, meaning that there is a difference between the means, one way or the other. You could also have a less than statement, meaning mu1 is less than mu2 significantly. Or you could have a greater than statement, which means that mu1 is greater than mu2. Now it doesn't really matter how you write your alternative hypothesis. You can either put your means on the left-hand side with zeros on the other side of the symbols, the inequalities or the not equal to's. That's fine, and that's how many books do it. Other books will do it where they set the means equal to one another, and the alternative, they are not equal to each other. The first one is smaller than the second one, or the first one is larger than the second one. It just really depends on your book. The critical value method, if you're doing the critical value way, the traditional method of hypothesis testing, you'll need a T of alpha with a minimum degrees of freedom. Degrees of freedom, the minimum between n1 minus 1 and n2 minus 1, which is outlined right there. Now that's if you're doing the critical value method. If you're doing the p-value method, you're going to want to do a 2-sample t-test in your calculator. And the pooled standard deviation is no, meaning there is no pooled standard deviation. Pooled standard deviation is reserved for if sigma 1 equals sigma 2, and we're not assuming that here. We're just assuming that we don't know them at all. So we're going to be doing a t-test. Our test statistic for the critical value method would be the means divided by the square root of their variances, both divided by their respective sample sizes, as outlined in this formula. Then we would go to our decision, and we would either reject or fail to reject, and then we would of course write our conclusion based on the evidence. There is no, significant, and you fill in the rest. So this is just the brief theory about testing the difference of means when sigma 1 and sigma 2 are unknown. On the next page there's an example, and I will be doing both the critical value method in a video and the p-value method in the video. Please pick the method that works for you.